Earth, Formation and Climate. Think Different, version 2. Looking at the globe, we are impressed by the vast expanses of water on Earth. Meanwhile, we may wonder why the land takes up only in the eastern and northern hemisphere. What would it look like if all the water on Earth dries up and exposes the hard Earth crust? In modern geological theory, it is believed that the Earth's 7 continents were formed by the drift of continental plates. But if assuming that the Earth was formed by the condensation of particle clusters ejected from the solar nebula, some detailed processes need to be added. When the ejected particle clusters left the solar nebula, they continued to rotate around the center of the solar nebula due to inertia. If there are no further reactions in the particle clusters, after the clusters cooled down and condensed into a planet, its revolving and spinning periods would be the same. It will be facing the sun with only one side, just like the moon. The moon's spin period is 28 days, its revolving period around the Earth also is 28 days, so the moon always faces the Earth with one side. However, when the hot particle clusters ejected from the solar nebula, they continued the nuclear fusion reactions and continued to eject particles around. Thus, the whole particle clusters started to spin around their center. The spin period is no longer the same as their revolving period. When the particle clusters finally condense to form the Earth revolving period is 365 days and its spin period is 24 hours. Left picture, the hot particle clusters. Right picture, the outside clusters cooled and condensed to form the shell of a planet. As the hot particle clusters cooled down, atoms and molecules were formed. High melting point iron and sulfur compounds condensed and became molten magma. During the process of condensation and magma formation, a celestial body might pass by the northeast surface of the cluster. Under the influence of celestial bodies, the magma flew towards the northeast direction and accumulated there. As the magma cooled down further, it formed the thick crust shell in the northeast part of the Earth. The hard shell also kept the core at high temperature and the nuclear reactions continued. As temperature outside the Earth crust dropped further, the suspended water vapor started to condense and pour down as rain. The rainwater filled up all valleys on the crust surface, forming oceans and lakes. While high lands emerged from the water to form lands and islands. The rainwater dissolved large amounts of soluble salts in the Earth crust. Sodium salts, potassium salts, halides, etc. Washed them away into oceans, made seawater bitter and salty. However, the rivers and lakes' water are often renewed by melted snow, therefore not salty. The magma in northeast hemisphere condensed into land of Asia, and the waves condensed into mountains. Since the magma moved from south to north, the waves condensed into the mountains run east-west. Such as Altai Mountains, Stankoff Mountains, Tian Shan Mountains, Himalayas Mountains in Russia, Mongolia and northern China. In the South Asia, magma moving became slow. The top layer of North magma gradually separated itself from the South magma. As water was filling up the rift valleys, the Pacific Ocean and the India Ocean with a series of islands were formed. The last remaining piece of magma formed the land of Oceania. Today, the magma under the Indian peninsula still pushes northward due to inertia. It inserts into the lower part of the Tibetan Plateau. This makes the Himalayas increasing height every year. Meanwhile, the land pushing and inserting result in turning nuclear products from the deep underneath crust to the top. Rich mines of heavy metals and radioactive elements are found in China's Xinjiang area. They are the later products of nuclear fusion and the later elements in the periodic table. From Asia to Europe, the direction of magma flow gradually changed from south to north into from west to east, therefore, the Ural Mountains dividing the two continents run north-south. In continents of Europe, the Middle East and Africa, magma moves even slower due to distance away from the interaction spot. The top layers of magma were divided into several parts. When water filled in, there emerged Mediterranean Sea, the Red Sea, and the Persian Gulf. The West Hemisphere is even farther away from the influencing spot, the magma there moved very slow. The top layer of magma was totally separated from the magma of the East Hemisphere, with filled in water, forming the Atlantic Ocean. However, the West Hemisphere magma still moved slowly in the east direction, therefore left a series north-south mountains and hilly landforms on the North America crust. The south magma was also dragged by of the north magma. Because of the slow movement, the north and south magma are not separated, but pulled into a long and thin strip between North and South America, forming Latin America. The continuous nuclear fusion at Earth core produces huge heat and high-energy particles, which induced the Earth crust expansion and volcanic eruptions. Although volcanoes, earthquakes, floods and tides have changed the Earth topography over time, the geological topography of large mountains, lakes and oceans can still provide insights of the original magma movements. Mountains in Asia run east-west. Mountains in North, South America and Latin America run north-south. The large mountains' running directions are related to the magma flow direction as it was cooling into solid. Like magma, gas molecules were also concentrated over the northeast part of Earth. As temperature dropped, water vapor condensed into rains. The rainwater fallen onto Earth further froze into ice and accumulated there. As time passes, the Arctic crust has been covered with thick ice and snow, becoming the Arctic Ocean. While at the south pole of the Earth, it is very far from the interaction spot. The magma just disconnected from the magma of South America, formed Antarctica. Although the land surface is also covered with ice and snow, the volume of ice and snow is much smaller than that of the Arctic Ocean at the North Pole. The spinning and revolving of Earth cause the air and water on its surface to move, then influencing Earth climate and ocean tidal movements. Earth rotates from west to east. Ocean moist air also flows from west to east, then brings abundant moisture and rain to the continent's east coasts. Whereas the west coasts are relatively dry. These are very clear in Australia, California, and southwest Africa. Moon orbits Earth in a 24-hour cycle. The periods of tidal movements is also about 24 hours. Therefore, people think that the ocean tidal movements are caused by Moon gravitational force. But is Moon's gravitational force strong enough to influence Earth water flow? Maybe the tidal movement could be explained in another way. The ocean water flows with Earth spinning. But water flows slower than the land. The movement of the ocean's water always lags behind and then taps the east coasts of continents. When the ocean water reaches the land, it will be pushed back and tap the west coast. It is like moving a basin of water, the water always splashes back and forth to hit the basin wall. The same happens to the tidal movement. Every 24 hours, the ocean water hits the east and west coasts, causing ebbs and flows. Earth spins and revolves around the Sun. It is very similar to a spinning gyro also revolves along the direction of Earth gravity. However, During precession, the spinning gyro changes its spin axis orientation all the time, while Earth does not change its spin axis orientation in its precession. The orientation of Earth's spin axis has a huge influence on Earth's climate. Since Earth's spin axis does not change its orientation in the precession, there are 4 seasons on Earth. All living things can flourish and develop. If Earth's spin axis oriented around the Sun in the precession, it would pose a huge threat to the life on Earth. Hot places would be very hot, cold places would be deep cold. The climate would become extremely harsh for all living things. The Earth might become a dead planet. Usually only when a spinning gyro slows down and becomes unstable, its spinning axis stops changing orientation with the precession center and staggers around. Since Earth does not change spinning axis orientation in its precession, our planet seems to be in an unstable state. With the Earth's huge mass, fast spin and precession speed and long precession period, changing its spin axis orientation could take a very long time. It has been more than 5 billion years since the birth of Earth. Scientists have found that there have been several biological development cycles on Earth. Each cycle lasted about thousands of years, and between cycles there are ice ages, which lasted about hundreds of thousands of years. Perhaps these cycles are caused by the orientation change of Earth's spin axis. The table summarizes the glacial cycles over the past 450,000 years, in Utah, USA. The average temperature during the glacial period is about 15 to 20 Fahrenheit. -9.44 to -6.67 Celsius. And the average temperature during the interglacial period is about 35 to 40 Fahrenheit. 1.67 to 4.44 Celsius. The glacial periods last about several 100,000 years. And the interglacial periods last about several 10,000 years. In recent years, Arctic ice and snow have been melting. Huge waves attacked some coastal areas. Increasing rainfall causes floods in some areas. Also, earthquakes and landslides occur frequently. What causes the climate change? There are blames to the rising concentration of carbon dioxide, which contributes to global temperature rise. According to the history of Earth, periodic temperature change is not a rare phenomenon. From the previous analysis, the Earth's spinning axis orientation change can cause climate change. Recently, a shift of Earth's magnetic pole was detected and aurora was observed outside the Arctic Circle. All these suggest the Earth's spinning axis orientation might be shifting, which may be the reason of climate change. Reference. Thanks for watching, goodbye.